Question 19. Here are two function machines, A and B. Okay, so function machine A, you've got an input. It takes away 3 and then squares and gives an output. And function machine B, you've got an input. It squares it, it adds 2 and gives an output. Both machines have the same input. Okay, so there's the same input going in. Work out the range of input values for which the output for A is greater than the output for B. So the real trick here is to realize that you can model this algebraically. And that has got to be a question when you're not sure, can I model this algebraically? And the answer here is yes. So if, let's say, the input is x, then what we're saying is that what we will need to work out is the range of input values for which the output A, so this, is greater than that. So we can model that algebraically. What I've got here is x for A, yeah, take away 3, and then square that. Now I'm not squaring the 3, I'm squaring all of that. So that is what I've got. So x minus 3 squared, and I'm saying I want the values for which that is greater than what you get for B when I algebraically model it. So if I algebraically model B, I've got x, I'm going to square it, and I'm going to add 2. So I've set up my equation, and that's probably the big stumbling block. One of the big stumbling blocks in this question, the main biggest stumbling block in this question. Once you've got that, you can then work through it a bit, and then you'll just have one tricky bit at the end, we'll see. So x minus 3 squared, I like to write that out as x minus 3 times x minus 3. So that's what I'm going to do, x minus 3 times by x minus 3, because then I can apply my FOIL or my grid method of multiplying it out, whatever I would like to do. So I'll use the FOIL method. First, outer, inner, last. First is x squared, then so outer, x times minus 3 is minus 3x, inner is minus 3 times x, which is minus 3x, and last is minus 3 times minus 3, careful with it, it's plus 9. So that is greater than x squared plus 2. So I've got a situation of, I'm just going to collect these like terms, x squared minus 6x plus 9 is greater than x squared plus 2. Okay. So, what can I do now? Well, the good thing is that I've got an x squared on both sides. So I can get rid of my x squared altogether, which is really nice. So I'm going to take away x squared from both sides. So that gives me minus 6x. I'm going to have to go over to here in a minute. So minus 6x plus 9 is greater than 2. So when is this the case? When would minus 6x plus 9 be greater than 2? Well, before I carry on, let's just complete this picture by taking away 9 from both sides. So I isolate the x's on one side. So take away 9 from both sides. That gives me minus 6x greater than minus 7. And this is the only part where inequalities are slightly different from equations, because at this point now you would want to divide both sides by minus 6, and you can do that. So you've got x, so that would, if I divide both sides by minus 6, divide by minus 6, divide by minus 6. So you see this is carrying on over here. I've got x, and over here I've got minus 7 over minus 6. Okay, So x is greater than minus 7 over minus 6. But minus 7 over minus 6, you know, I don't really want that really. So this doesn't really work. Okay, and this is where the whole thing with inequalities becomes a little bit tricky. And I strongly recommend that you check out the My Maths lesson on negative inequalities, which takes you through this. But what it is I'm going to have to turn the sign around when I've got these negative inequality. So I will end up with x, and I can get rid of the negatives as well. So, but I need to turn the sign around, so it gives me x is less than 7 over 6. And that's my answer. The range of values for which the output of A is greater than the output of B is anything where it's less than 7 over 6. So let's take an example of that. So less than 7 over 6 might be 1, because that's just over 1. So if I use that as an example, so 1 should work. Okay, so if I've got 1, I do 1 take away 3 equals minus 2, and I'm going to square it. Minus 2 squared. So it's 1 take away 3 squared, which equals minus 2 squared, which equals 4. That's for A, right? And for B, I would get 1 squared plus 2, which is 1 plus 2, which is 3. So we see that it works. Anything less than 7 over 6, 1 definitely works. So I'm just checking it with that. Now, let's take a value over 7 over 6. So we'll take a value, let's take the value 2 as something which is more than 7 over 6. So this shouldn't work, as in the value of B should be actually greater than the value of A. So let's have a look. So A, if it's 2, then I've got 2 take away 3 squared. So that gives me minus 1 squared, which is 1. And if I do B, that gives me 2 squared plus 2, which equals 4 plus 2, which is 6. So it doesn't work for that value. So anything less than 7 over 6 is what we're looking for. So I just need to write that in here. X is less than 7 over 6.